Time.
Okay, welcome to the Joke Wrocław. I'm really glad that you all came here. Today our guest is Josh Long. We are happy that you agreed to our invitation and you are here today with us. Even more because it's really late at your time zone. Everyone who watched this on the screen on this stream can win JetBrains license. To have a chance, you just need to be active on the YouTube chat. If there will be a question, we will ask those after the presentation of Josh, and I hope you will all enjoy this. Josh, stage is yours.
Thank you so much for welcoming me, for attending. I appreciate the invitation. I appreciate the opportunity to speak with you. Thank you so much, everybody. Truly, I am so sad that I could not be there in person, but it is a very strange year, and so whenever somebody sends me an invitation to speak at a virtual Java user group this year, I am even more grateful than the opportunity to come in person, because it means that we're still trying to make it work, even though the circumstances are not ideal. And I love that. I love that about our wonderful community. Dziękuję, that means thank you, right? So thank you so much for everything. Seriously, I hope you're all healthy and happy. It is after midnight on my time, so let's get started. We don't have a lot of time. I'm gonna stay and answer the questions for as long as you want at the end of the presentation. Okay, I have no place to go, no plane to catch, nothing. So we're gonna have questions. I promise I'll answer everything, and we can have a conversation, etc. Even after we're done with our presentation, even after our conversation is finished and I've answered all the questions, you may still have some more questions. And if this happens, I want you to find me on the internet. My Twitter is @StarbucksMan, StarBuxman, and my email is josh@joshlong.com. I am very happy to answer questions or if I don't know the answer, which is very common because I'm not a very smart person, when I don't know the answer, I'm very happy to send your questions to the smart people that do know the answer, right? My superpower is I know who knows, even if I don't know, okay? So don't hesitate, please. We on the Spring team are very happy to help. We're at your service, and we're also grateful for all of you. A little bit about myself. My name is Josh Long. I work on the Spring team. I've been on the Spring team since 2010. I am a Spring developer advocate. I'm a Kotlin Google developer expert, GDE. I'm a Java champion, and I'm just a very big fan of the JVM space and the communities that are in that space. So again, very much that's very much you. That's very much what we're doing here. That's very much everything community. As part of my work, I've been lucky enough to travel. I've got some videos that I did that are on Safari. It's a prefix, right? So you pay the same amount every month and you can watch all the videos and others if you want. I have a book called Cloud Native Java. This book is all about how to build applications that survive and thrive in the cloud using Spring Boot, Spring Cloud, and Cloud Foundry. I have a podcast that I do every Friday where I talk to people that are smarter than I am about Spring and Java and the ambient sort of adjacent communities. And it's not hard to be smarter than I am. So I have a lot of great people to talk to, lots of great people that I have conversations with. We've had lots of good conversations there. I do a blog every Tuesday. It's called This Week in Spring. It's a roundup of all the stuff that's interesting in the community every Tuesday on spring.io/blog. I do a screencast every Wednesday. It's called Spring Tips. It's a playlist on YouTube. So bit.ly/spring-tips-playlist. And of course, I'm working on a book called Reactive Spring. Now we're going to talk about Reactive Spring today. So maybe you do not need to buy this book. This book, you can buy it now if you want, but if you don't want, that's okay, because we're going to talk about a lot of it right now. This book is early. It's not yet done. So you can buy it, you can start reading it, and when the final edition comes, you can buy you will be given that. It comes for free, right? Even if you buy it now. But maybe you don't need to, and so that's okay. I'm hoping that you don't need to. I'm hoping that you get enough out of the next couple of hours to be productive. So I'm not going to change my screen. Everything is going to stay still for just a few minutes, okay? I haven't, my connection has not cut out. That said, my connection may cut out. So as long as you hear me talking, everything's okay. But I've been having some weird issues here where my internet sometimes disappears for a few minutes. If that happens, don't worry, I'll be right back. It's okay. That's a good time for you to go to the bathroom or something. I'll send a message on Twitter, a direct message, and we'll coordinate from there. But I don't think it'll happen. It's late at night. It hasn't usually happened late at night. Okay, so we're going to talk about reactive programming. In order to appreciate reactive programming, we need to consider what motivates the use cases for reactive programming. Now, reactive programming is not a new idea. It's an old idea. It's a thing that's been around for a long time. And the idea is that we want something that allow us to build software that is better capable of addressing the demand that we have seen introduced in the last 12, 15 or so years. This demand stems from a couple of different things, a few different things. First, the rise of the smart client, or the return of the smart client, right? We've now seen a return to the client service architecture. And so we see things like the iPhone, the Android devices, tablets, TVs, cars, your microwave, everything, right? Everything is online, IoT, right? And so this has created new demand for our services. The other thing that has driven demand for our services is the introduction or the rise of the microservice, right? And so now, whenever you look at a user interface, you're not looking at one user interface painted on the server and then rendered back to you as an HTML payload. You're looking at an API-driven client, something that has in turn resulted in tens or hundreds of API calls and network calls that in turn result in responses that may in turn themselves result in other API calls, all of which end up on the client. So now these two things have meant that we've got a lot of network activity, a lot of concurrency, a lot of resource usage, and the traditional approach to building software does not work. So when I say the traditional approach to software, it's important to spell out what I mean exactly. What I mean is that traditionally, when you looked at infrastructure on the JVM, traditional JVM-based applications had a very simple formula. A server socket rather, sits on port 8080, listens for incoming requests. As the requests arrive, the server socket is in a while loop, and it accepts the incoming sockets, and it takes the incoming socket, and it starts sending back data to the socket in the output stream for the server socket, right? And so both sides, both the server socket and the socket, have an input stream and an output stream, and they use that to communicate with each other. But input streams are blocking APIs, right? Output streams as well. So when I say input stream.read, I must wait for the response from input stream.read. This is something that happens on the thread that is being used to make the network call, okay? The problem with this is that while I'm waiting for that next byte, I cannot reuse that thread. So this is a problem, right? This is the first problem. The other problem is that now that we're doing this, now that we're moving to this increasingly network-centric architecture, where increasing amounts of data are being conducted over the network, we're seeing that the tools or the APIs that we have to handle control flow, especially for sometimes volatile network-based services, those tools no longer work. The patterns that we have to address that volatility just aren't elegant, right? They're very inconsistent. They're hard to get right, and people end up reinventing a lot of patterns for different protocols and so on, all because they don't understand the true problem, which is that we don't have a way to deal with this in a common way at the API level. So these two problems are what reactive programming aims to solve, in my mind, in my view. So the first problem is about making better use of those threads that we've got. The problem is when you look at typical infrastructure based on traditional JVM-based code, the threads are expensive. Threads are expensive. They're not infinite. And as a result, when you do a traditional input stream and output stream, you waste the use of threads, and that makes it hard for you to scale up. Okay, this means that if you log into a service, 10 years ago, you might see that service is unable to accept any new traffic, and yet the CPU is idle. It's doing nothing because it's just spending all of its time parked in the threads waiting for something to happen. Nothing is actually happening. This is a terrible situation to be in. The way we can fix this is by writing code that jumps off of those threads as soon as we have the opportunity to jump off of the thread. This is easy to do for the network layer because we can use asynchronous IO. Asynchronous IO changes the way that we think about input and output. We say, I'm asking for the data, and when the data arrives, I'll process the data, but not any sooner, right? I don't want to try to read the data when there's nothing here. I just want to have a callback. So that's the first problem. That's the first thing we can do is use something like asynchronous IO, but that's an inverted style of control. Rather than pulling the bytes out of the input stream, instead, the producer is sending us, is pushing the bytes to us when the bytes are available. So this is a different way of writing control flow code, which means that it's going to require some changes in the way that we write software. It's going to require some changes in the APIs that we use to support asynchronous IO. Here is where a good abstraction supporting these reactive sort of asynchronous streams would be very useful. The other problem, as I say, is we have now this increasing number of network services and network calls and that increasing volatility. And here we need operators, we need tools that make it easier to orchestrate multiple services, that make it easier for us to compose different disparate services and data. We need APIs that make it easier to handle failure in the network layer and in the handling of those streams, etc. All of that needs to become easier. So in both of these scenarios, it becomes useful to have an abstraction that we can use to handle these kinds of inconsistencies, these kinds of problems. And this is where the reactive streams specification comes in. In 2015, the reactive streams specification was born out of the work from the Netflix RxJava team, the Spring team who worked on Project Reactor, Lightbend, at the time they were called TypeSafe, who had Akka and Akka streams, and of course the Eclipse Foundation, who have Vertex, right? So all of these different projects are, original contributors to this reactive streams de facto standard, on top of which we have since released a lot of additional support, because the reactive streams types are very simple, but they're not nearly sufficient for our use case. So we've got extra support on top of that from Spring. Spring provides, since 2017, Spring has provided reactive support in Spring framework itself, the lowest level of Spring, right? On top of that, we have since released Spring Boot, Spring Data, Spring Security, Spring Cloud. All of these different projects and more now support reactive programming. So my friends, that's the journey that we're going to walk today. That's what we're going to look at today, is how these things compose, how they hang together, okay? So we're going to go back to, we're going to do that by going to here, my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It's better than Disneyland. But if you don't already have code in production, if you have not been to production, then you can begin your journey here at start.spring.io. What we're going to do is we're going to build a new application. Now, we're going to use Maven or Gradle. It doesn't matter. I'm going to use Maven. It's fine. We're going to use Java. You can use Kotlin. Kotlin's a great fit because we have native coroutine support. For everything that I'm going to show you today, everything that you're going to see today also can be done as coroutines, right? Because all these reactive APIs have been automatically turned into coroutine support for you if you're using Kotlin. And so you need to understand this reactive stuff, but it becomes much easier to express it using coroutines if you're not familiar with reactive APIs. So, but you are using Kotlin, okay? And then we're going to use Spring Boot 2.3. Now, 2.3x is the right version of Spring Boot to use. There's a lot of nice features there that make it a very nice, obvious choice for developers today. First, it has a lot of new features that make it more natural, more of an excellent story in the cloud when it comes to things like Kubernetes. Availability probes are built in. There's an easy command you can use, Spring Boot build-image to build a Docker image out of your application. You can use the layers configuration inside of the Spring Boot Maven plugin to divide your application Docker image into multiple layers, supporting your application classes, your static application dependencies, your volatile application dependencies, etc. There's just lots of stuff, lots of graceful shutdown. So if you want to have if your platform kills your container, you can make sure that the application drains existing workloads first, and then after a certain pre-configured time, then it shuts down. So it'll stop accepting requests, but it'll drain the incoming traffic first, and then allow everything that's in transaction, in flight, to finish off before it kills the node. So all these very convenient features. One of my favorite features is that it has now support. It's the foundation for our Spring Graal native image support. Now, Graal, Graal VM, is a project from Oracle Labs that supports building. Well, first of all, it's a C1 just-in-time compiler replacement. Okay, so that's very convenient. But it also provides a bunch of other tools that are extra, that go above and beyond what a regular JDK does. And as a C1 just-in-time compiler replacement, it's already very compelling and worth using. But there's some other things that people like. It's got a polyglot VM, so you can run Python code, Ruby code, R code, Java, Scala, etc. You can compile all that using the same thing, and these applications can talk to each other. That's one thing. The other thing that's really nice is that it has a feature called native image builder, right? Which in turn takes your code, and instead of doing just-in-time dynamic compilation, it actually takes your code and pre-compiles everything so that it's a native image from start to finish. There's no interpreted bytecode at all. And these native images are architecture specific, of course, but they have a lot of nice features. They're very fast to start up, and they take very little memory. So I've got a few examples here. I'm not going to show you how to do this because it takes forever to compile. So Spring tips, Spring and Graal part 2. Just look for this video. I did this video a few weeks ago. There's actually a blog as well that you can find here So find this, find the blog. It shows you everything in step by step. This is June 16th, right? So just a little bit more than 3 weeks ago, I guess. So that's here. It takes several minutes to compile these applications, so I don't want to waste all that time, but I will show you the results, okay? Here's a Spring Data JPA example using Apache Tomcat and Hibernate, okay? So target native image JPA. Okay, there we go. Take 2, there we go, that's better. So 0.212 seconds. There you go, that's our application. If I go to the browser, localhost, customers, and voila. Okay, there's the data from our customer's endpoint. Now, if I Control-C this, refresh, nothing there, right? So that's very, very impressive for me, at least. And if we go back here, one more level, we've got a MongoDB example. So this is using not reactive. You can do reactive as well, but I'm using the not reactive MongoDB support, and I'm using Apache Tomcat. So very similar in nature to the thing I just showed you. Okay, there we go. I just restarted it. There we go, 0.146 seconds, right? Very, very quick as well. So less than 0.2 of a second. And there's the data from that one. Control-C. And we go here to now the reactive example. And the reactive one, of course, because it's reactive, it's going to be much less memory intense, right? It's going to use much less memory. And it, of course, is faster. So 0.115, less than almost 1/10 of a second. And this is talking to a SQL database, returning the data. There you go. And it's using the reactive web stack, not Apache Tomcat, but Netty. So these examples are all there in that video. Anyway, all this is to say, I love Spring Boot 2.3. Lots of good stuff there, okay? I encourage you to check it out. So that's one thing we're going to do is we're going to use Spring Boot 2.3, and we're going to use the latest and greatest version of Java. You don't have to. You could use Java 8, but you shouldn't, right? This is an important distinction. Just because you can doesn't mean you should. In this case, you definitely shouldn't. Java 8 is technically inferior in every way. It's slower, it's got less security features, it's less robust, it's less performant. It's just a terrible choice in 2020 to make on purpose. I would avoid it if I were you. You have two other choices here. These are actual choices, Java's 11 and 14. Now 11, of course, is the current long-term supported version of Java. You can use that if you want. If you are a coward, it's fine. Java 11 is the long-term supported version of Java, but that's, why? Just use Java 14. It's faster. It's got a lot more nice features. And yes, you have to upgrade in 6 months, but it's Java. I mean, it won't take 6 months to figure out whether your software runs on a version of Java. You can just replace it. If you're in a cloud platform, most cloud platforms can automatically move you to the next version anyway. So I would just use the latest and greatest whenever possible. Water. Okay, so we've got that. Now let's add some selections. We want to use the reactive web support. Want to use R2DBC, use Postgres, use Lombok. What else do we want to use? RSocket, security, right? Lots of good stuff. I'm happy with all those selections, I think. So reactive web, R2DBC, Postgres, Lombok, security, RSocket. Oh, I forgot MongoDB. Let's do MongoDB just in case. There you go. So let's hit generate and go to the downloads directory. And what I'm going to do is I'm going to open this up in my IDE. Any IDE will work just fine as long as it supports Maven or Gradle and or Java 8, 11, or 14. Soon to be 15 in a few more months, right? 4 months, I guess. Now, okay, let's see. This is going to open up. Service. Did I choose Kotlin? Oh. Who wants me to do it in Kotlin? But, actually, how about I do the second one in Kotlin? We'll do the first one in Java. And the second one in Kotlin, the second module. Is there a way to do a poll on StreamYard? I don't know if there is. If there is, talk amongst yourselves, and in about an hour or so, or like 45 minutes, let me know if I should do the second one in Kotlin. All right, hit generate. Service.zip. Okay, service. There you go. Public static void main, string application, blah, blah, blah. So what we're going to do is we're going to comment out some of the dependencies that we do not need yet. So for example, R2DBC, we don't need that yet. R2DBC Postgres, don't need that yet. I'll move this over here. Okay. Good. Okay, so what else do we want to comment out the security stuff for the moment. That should not be, if I die right in the middle of the presentation and I don't add security, it was not because I think we should not have security. It was just because I didn't get to it yet. Okay, so we definitely want to add it. We definitely want to include it. Okay, so good. So we have R2DBC, we have Postgres. What we have left is MongoDB, RSocket, and Spring Web Flux. Okay, plus Lombok. Now let's build an application. What we're going to do is we are going to build an application that writes data to the database. So I'm going to create an entity called a reservation. It's going to have a primary key or a document key called ID and another one called name. Now ID is the primary key that we can use to describe the unique key for the document. A document in MongoDB is like a table in a database, and a collection is like the table. Sorry, a document is like a row in a table, and a collection is like a table. Okay, so this is a single row in a collection. Okay, so this is the document DB document style. I'm creating an entity to map to my collection, to a single document in my collection. I could use case classes in Scala or data classes in Kotlin or Java 14's preview feature for records. All of these are great features that I could use instead of using standard getters and setters and all that stuff. But since I'm not using those for now, I need to just create getters and setters and toString and all this stuff. I could just create getters, right, with no constructor, with a required only constructor. So I could do that and required args, and I could do final fields in Spring Data, right? So that's no problem. So that's my type, and what I want to do is I want to persist this into the database. So I'm going to create a repository that manages the instances of reservation whose primary key is of type string. Now, this is a repository. A repository handles the reading, the writing, the updating, the deleting. There are several methods here that are obvious, I hope. Save, delete, find all, count, etc. All of these methods are very natural. What may not be natural are these types, these parameter types, some of which are very new, I think. The publisher is a reactive streams type. It comes from org reactive streams. It's a publisher that publishes data to a subscriber. The subscriber is the thing that consumes the data that comes from the publisher. When the subscriber first subscribes to the publisher gives it a reference to a subscription. This is very important. We will come back to this in just a second. When the publisher gives the subscriber data, the data arrives in the onNext method. When the publisher gives the subscriber data, gives the subscriber errors, those errors arrive in the onError method. And finally, when the publisher wants to tell the subscriber that it is done, it calls onComplete in the subscriber. So you can see the lifecycle: errors, data, errors, and then completion of data. The onSubscribe method is arguably the most important part. This onSubscribe method is what's used to give the subscriber, a reference to a subscription. The subscription is itself the thing that the subscriber uses to request more or less data from the publisher. So the subscriber can use this to say, hey, I want 10 more records, I want 100 more records, but it never requests more than it can handle safely, right? This is very important. We don't want our subscriber to be overwhelmed. So we give it just enough data. And who is in a better position to say how much data it can handle than the subscriber itself? That's why the subscriber is the one using the subscription to make these requests. In this way, the subscriber cannot be overwhelmed. It cannot be denial of service, right? This is very important in achieving flow control, right? This is not a new idea, of course. Ever since we had one computer on the same network as another, we had to worry about flow control. One side sends data to the other, and they go as fast or as slow as is required. And there's usually a negotiation, a protocol that's followed to ensure that this happens, right? TCP/IP and other protocols like that even have it to some extent in the protocol itself. So, very, very useful part of the API. The world of marketing sometimes changes things. And so while this is called flow control, for most people, you might also hear the term back pressure. Back pressure just means flow control. It just means having one side tell the other how fast or how slow it should go. Very, very useful in understanding, okay? So we've got these three types. There's a fourth type called a processor. A processor is a bridge. It's a source and a sink, a publisher and a subscriber. It's a thing that produces data and it consumes data. And that's it. If you understand those four types, then you understand everything about the reactive stream specification. As I said earlier, these are very basic classes, very, very basic interfaces. And so there are some specializations that come from Project Reactor that build on these reactive streams types. The first is called a mono. A mono is a type from Reactor that is a publisher. It ultimately is a publisher. This is implement publisher that produces 0 or 1 record. It also has a lot of callbacks for composition and orchestration and so on. So these are called operators: filter, map, flat map, etc. Lots of different very useful operators there. So it's like a completable future, except it supports back pressure. We also have flux. A flux is a publisher that produces 0 to n records, where n is potentially unbounded. It's latent, it's unbounded, etc. A flux produces a potentially infinite amount of data, but it could also just produce 0 records. It can produce 1 trillion records and then stop. It's up to the publisher, right? So Both support lots of operators. Both are very convenient types, and they both have their own semantics. One is like a completable future. One is like a Java 8 stream or iterator. Okay, but they both support back pressure. Now we have these reactive types. I'm going to use them to write some sample data to the database. Okay, so sample data initializer, and we're going to use an event listener here. Application ready event, and public void begin at component. Good. Now what I'm going to do is I'm going to write some data to the database using that repository that we just created. I'm going to inject it into the constructor. I'll use Lombok. Lombok makes it easier to synthesize that constructor. And here I'm going to say flux.just. I'm going to create some names. These are people that are on the Spring team. Obviously, I'm on the Spring team. Hi, nice to meet you. Madura is on the Spring team, obviously. Olga as well. Violetta as well. Yushin, she's also on the Spring team. Dr. Sire is on the Spring team. Marcin is on the Spring team. Stefan is on the Spring team. There we go. That's, what is that? Is that 1, 2, 3, 4, 8 names? Okay, and so for each name, I'm going to take the name and turn it into a new reservation, like so. So new reservation, and for each one of those, I want to take the data and I want to write it to the database. I could do map again, but look at what happens when I call save. Save returns a mono. It returns a publisher of T, a publisher of reservation. And so I don't want to have the accumulated value be a publisher of publisher like this, right? If I look at that, it's a publisher of reservation. I want to instead take the inner asynchronous reactive type, and I want to unpack it. We call that flattening it, kind of like the curve, right? For the coronavirus, we want to flatten the curve and also the streams there. So we can use these nice operators to flat map the stream. Okay, so now that's it's just a publisher of reservation, or you could just say a var, right? Now what I want to do is I want to actually see this run, but if I execute the code right now, up until this point, nothing happens, right? So what I want to do is I want to make sure that I subscribe. Now if I subscribe, then this will actually run. You see these steps up here, these are kind of like pipes in a pipeline. Water will the water will flow through the pipes in the pipeline, but only if you turn on the faucet, right? You have to turn on the water. That's what subscribe does. Now, when I run this program, it'll write 8 records to the database, and then it'll stop. Then it'll run again when I restart it, and then 8 records will get written to the database. Then I'll have 16 records, and then a third time, 24 records, and so on. So what I want to do is I want to make sure that I first delete the data. I say this.reservation repository.delete all, and then, only then, do I want to save the data, and then, only then, do I want to find all the data in the database, and then, and only then, do I want to find the records, okay? So there we go. That's the entire pipeline. It's gonna write data to the database. It's gonna read the data from the database and then print it out as the records arrive. And notice that I'm using a second subscribe variant there to pass in a consumer to handle the data that comes back. All right, so there we go. There are some people on the Spring team. You can see that we've got some names here, the UUIDs. If I go to Mongo, db.reservation.find, right, like so. There you go. So there's our record for Violetta on the Spring team, okay? Now, this is using a NoSQL database, right? NoSQL is a very natural place to write data-centric applications these days. Lots of good choices there. And we have a lot of good reactive Spring Data implementations, right? These are different from our regular Spring Data implementations that are not reactive, right? So Spring Data MongoDB versus reactive Spring Data MongoDB. These are 2 different projects with 2 different code bases. One is based on a reactive driver, and the other one is based on a non-reactive driver. So we've got reactive implementations for Azure Cosmos DB, for Google Cloud Firestore and Spanner, for Cassandra, MongoDB, Redis, Neo4j, Couchbase, and Elasticsearch. So lots of good choices there. But a question people often ask is, well, how do I talk to a SQL database? And it's not possible to use JDBC here. This is where we get into some trouble, right? JDBC is a blocking API. So what we have done instead is we've moved to support the reactive database activity with our own specification called R2BC. There are several different major database vendors that have started writing implementations for this. And so right now you can find good support for R2BC and MySQL or MariaDB, for SAP HANA, for Postgres, for H2, for Microsoft SQL Server, and others. I'm sure I don't even remember all of them, but there's more, right? There's always more coming as well. So it's now quite mature and it's got a lot of features. We're going to use R2BC and PostgreSQL. Okay, so I'm going to go back to my code, and of course this is no longer going to compile because it's not MongoDB. And second of all, it's a different domain model, right? It's not a UUID. It's not a string UUID. It's a monotonically incrementing primary key. Okay, there we go. So reservation, integer ID, string name, etc. There we go. That's the same application. I just had to change the types of the domain and the IDs for the domain model. Okay, let's restart the application. Go, go, go. Oops, I forgot to get rid of this type. And you know what? Now that I'm thinking of it, I also need to provide a connection string. So R2DBC dot URL, R2DBC Postgres localhost. Don't tell anybody my username and password, okay? This is a very, very secret thing here. Don't tell anybody. You should use Spring Cloud's ability to support 12-factor style external configuration, and keep that in your environment variables, or Spring Cloud HashiCorp Vault, or Spring Cloud config server or something. Okay, so there we go. There's our data. Let's see, Marcin, he's 1600. And we can go here. PSQL, U orders, select all from reservation. There we go, 1600 is Marcin. Okay, so we've got now SQL and NoSQL. Question, the natural next question then, of course, is, well, what about if I wanted to support more coarse-grained business logic? For example, transactions. Well, you could do that, right? You can actually just use @transactional. This is not really that interesting, right? It just works. You don't have to worry about too much about the fact that it works, as long as your methods return they're public and they return a publisher of some sort, right? As long as they return flux or mono or whatever, then this will be done inside of a transaction. The return value will be managed for you in a transaction. But the question, of course, is how, right? Think about how traditional non-reactive services work. In a traditional service, you have a method that gets invoked, and there's right before the method gets invoked, the framework, Spring, creates some storage for your current ongoing transaction. That storage is alive for the lifetime of that method. And as soon as the method is committed, the current transaction as soon as that method returns, the current transaction is committed if there are no errors, or if there are errors, it's rolled back. Okay, so very, very natural kind of thing. Here, what we're doing is a little bit differently, because that storage that we used in the traditional non-reactive world was assuming that everything executed on the current thread. And this is not true in the world of reactive programming, where the flow of execution can very easily jump from one thread to another. So we need some way to make sure that the storage lives for as long as the reactive pipeline lives, and on every thread that the reactive pipeline executes. So thread locals no longer work. So instead, we have in Project Reactor a context. And this context is something that you can use if you want, although you don't really need to most of the time. It's kind of like a dictionary. So just keys and values, right? Key 2, new date, right? Key 3, false. So it can be whatever you want, right? It's just arbitrary dates and arbitrary values and keys, okay? This dictionary will be available for the entire life of the pipeline. It doesn't matter if this step in the pipeline happens in like 5 hours on a separate thread, this data will still live with it, right? We don't have to worry about that. Even if the method that's being executed returns, the pipeline might not finish for another week, right? Or another hour or whatever. And so It's nice to know that we have a mechanism for propagating that state. You don't really normally have to worry about this, but as we'll see later, this is being used under the hood through Spring Security. It's being used in a number of other use cases as well. For Spring Cloud Sleuth. Sleuth is our distributed tracing abstraction. This is there as well, and of course for transaction propagation in Spring Framework using the Reactive Transaction Manager. This is working as well. So lots of different use cases there. If you have anything that requires thread locals in a reactive context, then this is what you should look at. Okay. Now we have our service. We have some data in the database. Let's build a HTTP API. So what I'm going to do is I'm going to build a Spring MVC style reservation REST controller. And this is going to just be a simple endpoint that returns reservations, publisher of reservation, return this. And all I'm going to do is I'm going to inject my reservation repository here. And this is a Spring MVC style endpoint, nothing fancy here. I'm just returning the data from the repository as I have it here, okay? But consider what I'm doing here. I'm just trying to create a single endpoint that returns an HTTP response when somebody makes an HTTP GET request to /reservations. And all of that for this one little endpoint takes 10 lines of code or so, right? 28 to 38, so that's 10 lines of code. We can also use a different style. We can use the functional reactive style. And this is, I think, for my endpoints, for most of my simple ones, especially, I just use this, right? The idea is that you can just use the DSL, and it's dynamic, right? So I can chain together my responses like this. I can actually say delete, put, options, head, whatever, right? I can just keep doing that as much as I want. I can have for loops and while loops and all that I can use to dynamically register endpoints. But this is pretty easy. I'm just going to inject my reservation repository here in the bean definition. I'll say reservation repository.find all, and that's the actual definition there. Replace that with a lambda. Okay. Request, and voila. Okay, there's the whole thing, basically. Now I don't need that or that or that or that. So that's the entire thing. So this one line achieves all of that, right? And then the whole bean definition, 31 to 36, so 5 lines of code, does what this all does. And of course, if I scaled it out, I could do a lot more, and it still may not even be 10 lines. So it's more concise. Let's go ahead and run this and see what we get. I'll drink some of this water. Uh-oh. What's the problem? Oh, transactional. You can't do void. Remember I said you have to return a value. That's the first time I've hit that error. That's good to know. Okay. So localhost 8080 / reservations. There's our data. That's working. And I can hear you say, so what? Who cares, right? It's just 8 records from a JSON stanza, a JSON endpoint, and I'm using a SQL database. So what? I could have done this yesterday, I can hear you say. Why wouldn't I just use JDBC and the servlet API? And you're right, that's fair. That's a very good and reasonable position to take. I'm not trying to persuade you for the moment that what I'm doing is different or better yet compared to the old way. What I'm trying to show you is that it's actually very similar to the old way, right? Consider, first of all, that I have written very little code, right? Let's get rid of the code I don't need. So don't need this. And this whole initializer, actually, I don't need that or that, right? That's all demo code. So get rid of that. That's actually my production application right there. That's the application that talks to a database that has an entity that has an HTTP endpoint. Okay, that's the entire thing right there. Is these 46 lines of code, and that's with lots of spaces and new lines and all that kind of stuff, right? Obviously, and plus public static void main, plus my imports, right? It's just 46 lines of code for all of that. So obviously, what I've shown you is not more code. Now consider we get a lot of benefits, and we're going to talk about those in just a minute, but we get a lot of benefits that we don't have using the non-reactive way, and yet I'm taking much less code to get there. That's the first thing. The second thing is that I've only shown you a few APIs. I've shown you HTTP and R2BBC, right? But what you need to understand is that when you use reactive APIs, everything uses the reactive streams types. And so you don't have to learn anything different. I would agree with you that the reactive streams types are a little bit more difficult to understand than the stuff that you already know, obviously. So if you have to learn anything new, it's going to be different, right? It's going to be harder compared to using whatever you know already. But they're not that difficult. And especially if you've already gotten comfortable with the reactive streams, if you've already gotten comfortable with Java 8 Streams APIs, then you should be very comfortable with the reactive streams types. You're almost there already. And while it's a small cost to pay to learn these types in the beginning, when you consider all of the APIs that you no longer have to learn, life is actually much simpler now when you use reactive APIs. So if you're not using reactive APIs and you want to do HTTP JSON from a REST endpoint, it's a different API, right? If you want to do, if you're using non-reactive APIs and you want to do server-sent events or SSE, it's a different API. You want to do Kafka, different API. I want to do RabbitMQ, different API. I want to do JMS, different API. I want to do WebSockets, it's a different API. All of these are different APIs. They're different ways of saying, here's data that may or may not be available eventually, right? They're not here right now necessarily. Some are here right now, but some might arrive in a minute or a nanosecond or a week or whatever. All of these different APIs have different ways of saying, here's an asynchronous stream of data, different ways of describing asynchronous control flow. With reactive APIs, you just have to know publishers. That's it. And because publishers are everywhere, because these reactive streams types are everywhere, you have a much easier time composing these types. It becomes very easy to take data from different sources and compose them together into one aggregate stream, right? This is a very, very powerful feature, especially when it comes to microservices and for network-based services, because now you can compose and orchestrate lots of different services in a natural way, in a consistent way. That consistency gets velocity. It gives you velocity. So in this way, reactive APIs take up not more. They don't take up any extra lines of code, first of all, right? But second of all, they're actually going to make it easier for you to develop when you start doing it, right? When you start understanding these types, because now you've just got one thing that you have to know, which is the reactive streams types. The other benefit to using reactive APIs, as I said earlier, as I suggested in the very beginning of this whole thing, was that you get much better resource efficiency. So let's take a look at something that demonstrates that, right? Reactive APIs are really useful when you have a use case that requires liveliness. Think about how you would implement something that requires fresh live data. In the old way, you would have to take that data and you would have to return. You'd have to have something that was connected on the network at the server socket, and that kept on polling for the data, right? So typically, this meant that you have to have a thread that wraps a server socket, and you would pull the data on the other side on the service. This thread would be dedicated to that server socket. That way, whenever the data arrived, the thread could take it from the input stream and then give it back to the client. Well, this meant that you were keeping a thread just to wait, just to sit there and wait for something. This doesn't scale. So things that require liveliness, where you can decouple the server socket, the thing that's doing the network connection, from the input stream and from the thread that's being used to process it, are very valuable wins in the reactive world. So for example, stock tickers, chat notifications, any kind of telepresence, anything like that are all very natural use cases. So let's build a simple service that returns an infinite stream of greetings. Okay, so it'll be a publisher that returns a stream of greetings, given a greetings request and return a greetings response, like so. Okay. So class response private string name, like so. Sorry, message is the thing that we want. So class greeting request, like so. Private string name. Come on. There we go. Now these are going to be DTOs basically. So I'll just use these types here, these annotations. Good. Now, I'm going to make this a regular Spring service, not that, service. And it's going to produce an infinite stream of value. So I'll say flux.fromStream, stream.generate new supplier. Okay, new greetings response. There you go. Okay, new greetings response. Hello, request.getName at instant.now. Okay. Alrighty, good. So there's my entire stream. And place that with a lambda. Okay. Good. There's my entire stream. Now that's going to be a lot. It's going to just produce data infinitely. So what I want to do is I want to slow it down, because otherwise, if I logged it, it would scroll down to the floor and out the door. So what I'm going to do is I'm going to use delay elements. Delay elements allows me to add time to my responses. I can stagger each result by 1 second. And this is very useful, and it's very easy to do because reactive APIs are asynchronous. There's an element of time involved, and that time is governed by a scheduler. The scheduler is a thing that that schedules the work. It moves the flow of execution from one thread to another. Now, again, you don't really need to worry about this usually, but if you do want to, you can easily. You can actually override the scheduler here. So you can say subscribe on schedulers.elastic, for example, right? You can override the scheduler. By default, the scheduler is one part timekeeper and one part thread pool. So the default scheduler has as many threads as you have cores on the machine. So if you have 4 cores, you have 4 threads. And this is fine as long as you don't do anything on any of those threads that would block those threads, that would keep them from being reused by something else when you're not using them. So it's very important that you never block. Imagine that you have only 4 threads and you start blocking on one of them. Well, now you're not blocking one user, you're blocking 25% of all your users, right? 1/4 of all the users in that system, in that service. That's a very bad result. So you must never block the thread. So we've given you a Java agent called blockhound. You can add blockhound to the class path. Here it is, and it's you can just add to the class path, and you say blockhound.install, and whenever you do anything silly like thread.sleep, it'll automatically throw a blocking operation error if you're doing that work on any scheduler that should be non-blocking. And of course, this is a generic abstraction. We have built an implementation to support Reactor, but you can also extend it to support other asynchronous kinds of use cases. We have an example that does Akka streams, for example. Now, I've got a scheduler. I've got my greetings service. In order to demonstrate this to you, I'm going to create a WebSocket endpoint. Okay, so class greetings WebSocket configuration. And here it'll just be a simple URL handler mapping. Return new simple URL handler mapping map.of ws greetings new, and then here I'm going to inject the WebSocket handler that does the work for me. Right? The actual business logic will live in this WebSocket handler object that we're going to create. So what I'm doing here is I'm telling Spring WebFlux, the reactive web tier framework that we're using, I'm telling it to map this endpoint, WS greetings, to my web service endpoint, and then map it to this WebSocket protocol handler. So when you create a WebSocket client, it first connects to the HTTP endpoint, then it upgrades to the WebSocket endpoint. Okay, so I'm going to create that. I'm creating that mapping. We also need to tell Spring Web Flex to look for WebSocket handlers themselves, like so. Return new WebSocket handler adapter, and finally, WebSocket handler itself, like so. Return new WebSocket handler. Good. So there's my WebSocket handler. And the WebSocket handler is where the business logic that we're going to create will live. So I'll use the greetings service here, like so. And when the WebSocket client connects to the WebSocket service, a WebSocket session is going to be established. I'll receive all the data that comes in. I'm going to take the data from the client and take the string, the payload, as the text. And these will be names, right? I'll use these as names. I'm going to take each name and turn it into a new greetings request, like so. And then I'm going to take each one of those greetings requests, and call the greetings service dot greet endpoint, right? So service dot greet greetings request. Alrighty, and then from here, I'm going to take the responses, the reactive stream of responses. So greetings reply or response, yeah. Greetings response. I'll take that. I'll get the text from it, and then for each one of those, I'm going to take the string message and turn it into a WebSocket session text message. So text message. And then for each one of those, I'm going to send it back to the client. So here we go. Message flux. We're going to say var replies, and we can just send the whole thing back like this. So session.send replies. Turn, and voila. Okay. Now, here's my reactive application. I'm going to use method references because I can clean it up. Turn this into a Lambda. There. So that's my entire WebSocket application. Now, obviously, this is the service side. I want to demonstrate it to you. So I'm going to create something on the client. And here, I'm going to do something that I would not do if there was any other way forward, if I could find a better way. But I fear that I cannot find a better way. And so this is the only way to do this. And I'm sorry, I would not do it in polite company if there was any other better way. What I'm going to do is I'm going to write JavaScript. So ws.html, body, script. Okay, window.add event listener, load, and const ws, new WebSocket, ws, localhost 8080/ws/greetings, add event listener, message. And here, when the socket is ready, I'm going to get an on-open callback. And here, I'm going to just send a request to the WS socket saying, use this name, okay? And when the messages arrive, I'll get a callback here, message, and I'll say I want to log it out. So console.log message.data. That's the entire reactive stream. Let's go ahead and restart. All right, there we go. There's my entire pipeline. So reservation, good, up and running. All the data is in response. Okay, so now if I go to localhost ws.html, show the console there. There you go. It says hello Spring fans, and it's returning the responses every second, forever and ever and ever. And that's okay, because in between those responses, in between the raindrops, the thread that's being used to produce the response is being freed up, and something on the service is able to reuse that thread to handle other requests. This is the real power of reactive streams, is that we can take our service and handle many more requests with the same infrastructure. We don't have to pay more in our data center spend. It's not about making any single one transaction faster. In fact, because there's a slight bit of context switching associated with reactive programming, you might find that some responses are just a tiny bit slower. It's not about making each one faster. It's about being able to handle many, many, many more transactions, right? That's the goal here. I can't prescribe you particular numbers because, of course, I don't know what your use case is, but go ahead and benchmark it for yourself to look for the scalability. Look how many more transactions can you handle with the same hardware. That's where you're going to see some amazing benefits here. Okay, so now we have a service that's up and running, and it's a thing that has WebSockets and has HTTP. And the natural next thing that I'm going to want to do, is to create a client, something to talk to my service. Now, is there a way for me to, let's see here, are there comments or anything like that? Anybody say anything about whether I should do Kotlin or not?
Yes, there is one person which asked you to make a Kotlin, so we can try this. And Michał is talking that you are really nice pronounce the name of the dziękuję. So yeah, it's a compliment for you. Yeah, there are two questions for you. I don't know if you want to answer them now.
Yeah, let's do that.
First one is from Przemek. I've heard that at the end, in most cases, JIT makes up faster than native image. Any experience with real working apps under heavy load?
In the end, most cases, JIT makes apps faster than native images. I don't know why that would be possible, because remember that the AOT native images, it's the same technology as JIT, right? It's looking at this, it's doing the same thing. So, but I don't know. It makes perfect sense that JIT would be slower since it's only part of your application. But I don't know. I do know that it's a different garbage collector, right? So when you use just-in-time compiled applications, you're not using the JVM anymore, right? The resulting binary is using something called substrate VM, and who knows? Maybe there's some performance delay there. That could be possible.
Okay, great, thank you.
But on the other hand, if there is a performance degradation, I just sort of wonder at what point do we do the math and say, okay, well, maybe with my just-in-time, maybe with my native image, I can run the application in 30 megs of RAM, but in a regular Java application, I need hundreds of megabytes of RAM, right? I can run it maybe in 20 megs of RAM, right? Versus a Java application, which requires hundreds, right? And so how many Java applications, is it going to be so much faster? Do the math. Like, can I run my native image code 10 times and still not take up as much RAM as my JVM-based application does? And if I run it 10 times, can I now handle the same scale as I would before? Even though I'm a little bit slower, I'm sure I could, right? I'm sure it would be much better that way. I can handle a lot more scale. And if you're saying per transaction, the time for a single transaction, maybe you're right. Maybe it's still slower. But in terms of if the performance is impacting my ability to finish something and then start something else, that's my throughput. And if that's a problem, then maybe I can just add more instances to the load balancer. And since it costs so little to start and load native images, maybe it's a better situation. I don't know. I'm just guessing. I'd be very happy to see some numbers there. It is early days yet. That's a good point.
Exactly. Okay, there is a second question. How does Bootiful mean something with the respect to the Spring?
Yeah, Bootiful is a term I started using years ago. It just means beautiful, like Spring Boot is beautiful. So anything that has that beautiful quality, anything that just makes it easy to focus on getting software into production and makes it fun, that's Bootiful, right? If an idiot like me can get software into production quickly, then it's Bootiful, right? Because if I can do it, then you can definitely do it, right? It's easy.
Okay, thank you. There is another question from Przemek. Do you think that
Sure.
Project Loom may lead to a shift from reactive stream implementations?
No, Project Loom is a lightweight thread mechanism, so it's a thread pool. There's no other benefits except that it's a more scalable thread pool, but it doesn't handle control flow, and we're going to talk about a lot of that stuff in the next hour, right? The next second half of that talk. It'll make it so that I can take old code, and that old code will work more efficiently. That is to say, I can handle more transactions in the old way, but it still doesn't handle the control flow issues and the patterns for building smarter service orchestration kind of use cases, especially in the context of microservices. I think Project Loom will make reactive streams even more appetizing, more useful, because now people will be able to handle a lot more scale, and it become very natural for people to want to be able to handle volatility there. Basically, the benefits that I just described, where Reactive removes all these extra APIs, that still applies even when Loom is here. Loom doesn't get rid of any of them. You still have to deal with 10 different APIs to do anything. So I think Loom plus Reactive is actually going to be a very nice fit.
Okay, thank you. So I think those are all the questions for now. So yeah, you can go further.
Thank you. Oh, and the other thing is, Loom doesn't give you a paradigm for dealing with concurrency, as we're going to see in a second. That you're still dealing with Java lang thread, and at the end of the day, this is very important. Remember, there's only one person who truly understands how to write multi-threaded Java code, and it's not you. That's the important message here, my friends. This is not a message of hope. I don't mean to be very sad, but it's not you. I don't know who that person is, but it's not you, it's not me. And so don't write low-level multi-threaded Java code. And you're going to have to do that in order to get efficient services. So that's the other thing, is Loom doesn't address that at all. It doesn't give you a good paradigm for structured concurrency. Okay, let's go to start.spring.io and build a new service. And by the way, I cannot wait for Loom. We're all super excited about it. That's, it'll help take old code, especially, and get it up and running. On the other hand, remember, Loom hopefully will come out Java 17. We're at Java 14, so a year and a half before it's out in GA, maybe. And then how many years before you can use it in production? So yeah, just a lot of reasons not to wait for Loom. It's not going to be the end-all solution. All right, so a client. All right, so we're going to go back here. So somebody said I can use Kotlin. We're going to use Kotlin. I'll show you some concepts. You don't have to use it, in fact. I'm going to use Kotlin. I can target Java 8 here because I still get a lot of nice features. We're going to use the reactive web support, RSocket support, security support. I guess that's it, actually. I don't need Lombok because I'm using Kotlin. So is that it? I think that's it. That's nice. Just three very small. Maybe I could do resilience for J first. A smarter circuit breaker. Maybe I could do gateway. I'm not sure if we're going to have time for these last two, but I'll try. All right, here we go. So UAO client.zip. Client. Generate. Alrighty. Alrighty, my friends. So client application. Here we go. It's a Kotlin application. I don't know how much of Kotlin you've had experience with, but here's a quick few things you need to understand. This is an annotation on a class. This class is a top level class. So this is the same thing as this, right? I don't need this. This is a top level function. So functions can be inside of a class, in which case it's called a member function, or it can be outside, in which case it's just called a function. Member functions are basically Java methods, okay, same thing. In Kotlin, the name of the variable comes here, then the type. There's no special syntax for arrays, so you don't have to say, none of this doesn't work anymore, right? It's just array of string, and functions have they're declared with fun. The return value, if there is one, is here at the end of it, right? Nothing or unit. Unit means void, right? But it's implied here, right? I don't have to provide it. But if I have a explicit type, I do need to provide it. So boolean, whatever, that kind of thing. Okay. Okay. So now what I'm going to do is I'm going to write an application that acts as a client to the service that we just built, and I don't actually care on what port this application runs. So I'm going to start it up on any random port because I'm not going to be using the HTTP services here. So let's build a Java configuration kind of application to talk to our service. So I'll create a few Spring Beans, fun, and here I'm going to create a HTTP listener. All right, listener. Now in Kotlin, if I want to define a bean or a Java configuration method, rather, I could do this. I could say it's going to return an application listener for an application ready event, and I can return, and I could say, okay, define application listener, and then there you go. That's basically it. I don't have to specify this again because the Kotlin compiler already understands that that's being provided there. I could, but it's redundant, right? The interface for application listener is a functional interface. So it's just void on application event. And so I could just, I could say application ready event. I get a pointer to that, and then I can respond to it by doing something here. Like I could print out the results that the application's ready to roll, right? But this is redundant, first of all, because I'm not going to use the application ready event. So I could just get rid of it. If I wanted to, I could use it. It means application ready event. It is an implicit parameter. In Kotlin, whenever you have lambdas that have one parameter, you can drop the explicit definition of the parameter and use it. I can drop this as well. I also, since the compiler already knows right here, I'm doing this twice, right? I don't need to tell it again. I can actually just drop all that and do an equals and get rid of this and get rid of that. And that's actually the same thing from the perspective of the compiler, right? It's a function that returns one value. It's an expression. So the function equals this one expression, right? The return value there. And I like that style, right? Very, very convenient. So what I'm going to do here is I'm going to, when my application starts up, I want a reference to a HTTP client or web client or reactive non-blocking web client. So I'll say web client, and that bean will come here, web client. And in order to build this bean, I need to inject the web client builder. So builder.build. Okay. There you go. And that's my reactive non-blocking client. Remember, HTTP is a protocol. There's nothing in HTTP that understands back pressure. So there's no way for there's no requirement that a reactive HTTP service have a reactive HTTP client. I can use a reactive non-blocking HTTP client with a non-reactive HTTP service, or vice versa, right? It doesn't matter. Either one is fine, right? Or both in this case. So I'm going to use the reactive HTTP client here to make a call to the service. I'll say HTTP, okay, HTTP dot get dot URI HTTP localhost 8080 / reservations, right? And the data that comes back is going to be JSON. I want to turn the JSON into types of data that match the type I have in the server side. So I'll show you a very funny magic trick here. I can create a class. Like I could do this. I could go here, and the JetBrains team have done a really great job of making it so that I can copy and paste code and have it automatically converted into Java. Oh, sorry, Kotlin. So I'm going to copy paste this code. And again, you should never do this. You should never do this. Never. Not even when you're all by yourself at home and no one is looking. Don't copy and paste code. But I'm going to show you what's happening here. See what I just did there? I pasted it, but it gave me this code it's technically okay, but it's not how you would write it, right? look at all this stuff that gets left behind. I don't have Lombok. It's an internal class, which is meaningless here for all intents and purposes. That's technically correct. But again, what I really want is a DTO. So in Kotlin, there's something called a data class. It's like a case class or Java 8 record. In Kotlin, fields that are immutable are val. If they're mutable, they're var. Okay. If they're nullable, the type has a question mark there. Okay. So now I can create a data class. I can say, okay, knowing that, I can say val id int val name string. That's the data class for this. Data class greetings request val name string. Data class greetings response val message string. Okay, so I don't need these types either. There you go. That's my entire Reactive API. Now I want to tell the framework to take the data and convert it into reservation classes for me. And then I want to subscribe to the data, and I want to provide a callback. So I can say, I could do this. I could say subscribe, and then provide a consumer like so. And then in the consumer, I could print out the results, kind of like in Java. There's a few things I can fix here, though. First of all, this is the Java signature here. What I'm doing is I'm providing a class literal. But in Kotlin, we have sort of pseudo-reified generics, right? So because of the way that Kotlin works, we can actually capture generic parameters at compile time and then insert them into the call site where we make the call, right? Where we make the network call. And because we can do that, we have kind of quasi sort of reified generics, right? It's still not quite reified, but it's very convenient. It only works for inline functions. You can see it's a function that's inline. That means it's like a macro. It's copied and pasted into the call site, and it's reified, which means that we capture the generic parameter. So at runtime, we can say t.class. You can't do that in Java, right? This only works for these kinds of inline reified functions. But if we do that, then we can actually ask, what is t.class? And then you can create new class. You can say, I want to create t.class.new instance, right? I can do all that kind of stuff. I can capture that generic type. So because we can do that, and the compiler lets us do that, we can actually just change this code to use generic signature, body deflex of reservation, and we don't have to pass in the type token. That's very convenient. The other thing that's nice is that in Kotlin, if you have a lambda like this one, if it's the last argument in a function, or if it's the only argument, you can just drop the parentheses. If it's the last argument, it can live like this, right? I can just do that. But if it's the only argument, then you don't even need that. You can just remove that. So it's the same thing, right? Very, very nice API there. Okay, so let's see what happens if we run this code right now. Here we go. And by the way, that reified generics, that's also what's happening here. I'm doing run application, client application. Oh, I've got a bunch of stuff I don't want just yet. I don't want Spring Cloud Gateway. So let's get rid of a couple of things here. Don't need this or this for now. Notice that when you create a new project on Spring Initializer, it automatically has the right modules for Jackson and Kotlin, and all that kind of stuff is just provided for you, so you have a working application. Alrighty, so there's our application. There's the data. You can see that worked. Okay, couple things. First of all, is this always going to work? If I call that downstream service, is that always going to work? I don't think it's always going to work, right? There's problems here, right? There's limitations because that service might not be available. And so hopefully you are using Spring Cloud's discovery client, and that way you can talk to Apache, Zookeeper, HashiCorp, Console, Netflix, Eureka, service registries, right? In this case, you can actually change the code, something like this, foo-service, right? Instead of using a hard-coded host and port. But this still doesn't guarantee everything will be available. So I want to make sure that my code is robust even when there's service outages or changes. So here I can use an on error resume operator, right? And here I'm going to say when I get an exception, right, I want to determine what to return as results. So I'm going to return a default value there. I'm going to control how. I want to map this first. It dot name. So I want to return. I want to determine how to fail. Basically, I'm degrading gracefully, right? If there's something wrong, I can also do a retry. I can say I want to retry 10 times, perhaps. I want to do a retry when, right? And then I say retry dot back off, and I can do 10 attempts. Dot duration dot of 10 time unit dot whatever seconds, right? So we're gonna do duration of seconds. There you go. So I can do that, right? I can actually say I want to do a back off 10 times, and then each time I want to back off 10 seconds, and so on. So I can do some very interesting things there to make sure that if this service fails, I do things the right way. I can also do a timeout. Timeouts are kind of interesting, right? I mean, I could time out for a day. That's ridiculous. I could do a timeout for a second, which is also really relaxed. But let's say it's a whole second, okay? I don't really like timeouts though. Timeout, you can use timeouts, of course. You should use them for the worst, the worst case. You should use them, but they don't really solve our problem, right? Most people who are using timeouts, they use them for their SLAs, right? SLAs are very important, but SLAs can be better served by other approaches. So think about what happens when we use a timeout. What we're doing is we are saying that our timeout, the timeout that we have in our service, is a number, and so we depend on other services, and those other services must provide a response to us within a certain amount of time. Otherwise, we need to abort that call and then try again. So imagine that our service has, let's say, for simple math, 10 whole seconds. That's a lifetime, okay? But let's say 10 seconds. 10 seconds, 10 seconds means that when we call the other service, that service that we depend on has to produce a response within 5 seconds, right? And then if that service fails, we can then retry and still return within 10 seconds, right? So we have one extra retry in there. What about that service? What if that service calls another one? So that service has to call another one, and it has to produce a response within 2.5 seconds, right? Because 5 seconds divided by 2 is 2.5. So the problem gets worse the further away we are from the origin of the request. It becomes very unfair just because you're further away from the origin of the request. So timeouts are not a good solution for what we're trying to do. There's another approach called hedging, right? So hedging. This is a orchestration pattern. It's a very common pattern in microservices, and many different organizations use it. Google has talked about using it. Netflix has talked about their use of it as well. Uber, the car company, taxi company, whatever, they use it. So a lot of different organizations use hedging, and the idea behind hedging is very simple. You want to make sure that you diversify the risk. So if you are gambling in a casino, for example, you don't put all of your money on one risk, on one option, because if you fail, if you lose, then you lose everything, right? It's very common sense advice. Don't put all your eggs in one basket, we say in English, perhaps in Polish as well, I don't know. Don't put all of your money in the same stock in the stock market, right? Just common sense, good advice. Here, what we're doing is we're not going to put all of our hopes on one host and port. We want to diversify the risk by hedging. So let's imagine that you're using the discovery client, and you're asking it for different instances of some service, okay, like this. So then once you've got this, you get back a list of service instances. Okay, and from there you can actually visit each one, and you can get the host and the port. Let's say that you get back 10 instances. You pick 3. Okay, so I'll leave it to your imagination. But let's say we've got host 1. Oh, that's Java. Val host 1. List. Okay, equals it's not a list. It's a publisher, isn't it? Publisher equals null. Okay, to do host 2 and host 3. So again, use your imagination here. How to, for the nulls, you can just do all this, right? Just copy and paste this, and up to here basically, and you'll have what I'm talking about, right? But imagine I've called host 1, host 2, host 3, and now what I want to do is launch all 3 at the same time. That way I get them. I want to get them all going at exactly the same time. The fastest one to produce a response, I want to then keep and then discard the other slower 2 calls, right? Now, there are many reasons why the other 2 might be slower. Maybe there's garbage collection on the service that they're calling. Maybe there is a pause, or maybe the service is down, or maybe the capacity is lower. Whatever the reason, you want to keep the fastest instance that returns. This has the benefit of getting you a response within your SLA. Maybe one of these hosts is not going to return in time, but hopefully one of the 3 will certainly return in time. But that's what we want, right? So this is what we mean. We're making the same network call to the same service, but on 3 different hosts and ports. Now, this of course means that you're going to be making the same request 3 different times. This is only good for things that have no observable undue side effects. That is to say, they are idempotent. If they're not idempotent, then of course this is a very bad idea. You should not use this pattern on the charge the customer credit card endpoint, right? Use it on some other endpoint. So I want to launch all 3 calls at the same time, and I want to get the first one to come back. Now imagine the network code, right? Imagine the threading code that you would have to write to get that. You'd have to do some very weird code to capture the fastest one, and then discard the other 2 and apply back pressure to them. This is a race condition. It's not code that you want to write, and yet this is the code you would have to write. So what I want to do is I want to let the operator from Reactor do it for me, and that's easy, right? It's very easy to do this kind of thing with Reactor. Here, I get back a stream, fastest publisher of string, right? So this is the fastest one. The fastest one is the one that I want to use, and it'll automatically apply back pressure. It'll automatically cancel the other 2, so they don't waste their time producing responses that I'm not going to use. So this is a very natural pattern in a microservice environment. It would be very difficult to do this without reactive APIs. You would not want to write this code by yourself, and you can do lots of examples like this. Imagine I'm calling, orders, and I'm getting back a publisher of strings. Okay, so just to do. Okay, and here customers, I'm calling the customer data, I'm getting back integers. I don't know, whatever, just it doesn't matter, right? And I want to get back, maybe I've got orders ordered by customer, and then I want to get the customers as well. So I know that each one correlates to each other, and so what I want to do is I want to get one of each. So I can say flux.zip orders customers, and what that gives me is a tuple. And I can use the tuple. I can say, give me T1, which is a string, and T2, which is an int, right? So maybe I want to concatenate them together. I can say tuple dot T1, tuple dot T2, right? T2 is an int. T1, you can see, is a string, right? And then I can subscribe. Okay, so very, very natural kind of thing to do. Obviously, this is expecting something not null. The compiler is upset with me, so I could do flux.empty, whatever. Okay, there you go. So that would work. Obviously, you want a real stream here, right? Not a null. But this is a very natural thing to express, right? I'm doing scatter gather kinds of composition, right? Another example, another project that I really like that supports these kinds of use cases is called Assembler. Assembler is not our project, it's a third-party project, but it has some very nice implementations, and it's designed to support, it's a functional, type-safe, and stateless Java API for solving the N+1 query problem in multi-database and microservice aggregation. So you can see there's an implementation for Project Reactor and WebFlex. And so the example here is very simple. The example, I like it, but I wish you need to understand this transaction.class. This is a generic domain type. It's not a framework type. It doesn't come from assembler. It's the sample application. It's a demo, right? So it could be any type that you want. It could be an assembler of an order or a line item or a customer or whatever, customer profile. So the idea is that it's an assembler of the transaction that has a correlation key. So the transaction correlation key is by the customer ID. And we get that by calling the get customers, right? So we're creating a reactive stream of transactions that have customers in them, that have relationships, one-to-one relationships for the billing info, again, correlating based on the customer ID. And we have a one-to-many as list, getting all the orders for customers, correlating on the customer ID, right? So once those reactive streams finish, then the aggregate type is created for us, the aggregate transaction type. And again, these are all reactive streams, so they all happen at the same time. There's concurrency involved, and the result is the most efficient result possible. So I'm making as many network calls as I need at the same time, and then I have this nice operator, this nice DSL to compose them all into one aggregate type, and then I can return that back as a stream back to the client that I care about, right? You don't see any threading code here. There's none of that craziness. It's just a nice, simple, deterministic DSL. So I love this kind of stuff. This is a very, very cool use case of reactive types, and it just so much simpler than trying to do it without reactive types. That's I guess the important part here. Okay, so we looked at hedging. We looked at the zip operator. We looked at and there's other ones. I just found one the other day that I'm using that I really like. So let's move that over here. Okay, zip hedging. The other day I found one that I use a lot now, called take and tell. So imagine I have a stream of data. So this is notifications from client, and it's a publisher. Okay, and you can use, imagine any network source, right? Any stream of data. And what I want to do is, while I want to keep processing this data, but only process it in as long as a telemetry stream is still producing data. So val telemetry from client publisher of Boolean equals flex.empty. Okay, so imagine that this is a never-ending stream as well. This is a never-ending stream of telemetry information, and I want to keep. So this is a flex.empty. Why won't it let me do that? Oh, okay, sure. So it's a Boolean. Okay, and what I'm going to do is I'm going to say, so basically, no, I'm going to filter it, right? I'm going to keep only the records that are false, right? So is client down, right? And so if the client is down, then I'll keep it. Otherwise, I'll ignore it. I'm going to filter it, right? So it's a Boolean, right? Very simple stream. So in theory, this will be a never-ending stream of results, but I'm only going to keep the last record, basically, the last result from that stream. So it's going to be empty for most of its life. Okay, imagine this comes from this is a never-ending stream, right? okay? And this is a never-ending stream of data coming from the client. Maybe it's, you know, gameplay action or whatever. I don't know. Doesn't matter. What I want to do is I want to take the data from the client and I want to keep processing it, but only as long as this is true, right? If it's false, or sorry, for only as long as this is false. As soon as it's true, that means the service is down, right? The client is down. So I need to, or the client can't produce the data, or it's stopped or whatever. So here I want to say, take this data from the client until the telemetry data stops or starts, I mean, right? And then I can map it. So I can take it, you know, I can do whatever I want with it. Print, telemetry, response from client, right? How cool is that? So this telemetry data, it's going to be empty because it's always going to be false. But if it's ever true, then it'll emit one value. And as soon as it emits a value, then this logic over here will stop processing the data from this stream of data. Very, very convenient pattern. Very, just, you know, supernatural. So many, so many operators that you get out of the box here. Okay, so we've got a number of different things that we've looked at to make working with microservices and working with reactive streams a lot easier, right? I think these patterns are useful for every kind of application, right? A lot of different applications are going to benefit from this kind of stuff. But what about HTTP itself? Can we do better than HTTP? Well, I think we can. We're using HTTP. HTTP is a nice protocol. It's a protocol that, you know, was designed for document retrieval. It's a very simple protocol. It doesn't support other message exchange patterns. It only supports request response. So if you want to send a message to a HTTP service, you'll get a response back. But other kinds of message exchange patterns, like bidirectional communication, like fire and forget, these things are not easy to do, or in some cases, they are impossible to do with HTTP, even with HTTP2. HTTP 1.x is also, you know, there's a lot of problems with HTTP 1.x. Some of those are fixed in 2.0. In general, though, for high-speed kind of services, they're not a great fit. They also don't understand back pressure. Remember, HTTP itself doesn't understand back pressure. So there's no way for an HTTP client to ask the HTTP service to send more data in 10 minutes, right? It can either get the data and then disconnect, or it doesn't, right? Or it cancels. So the best result that we could get if a reactive HTTP service connects to a reactive HTTP client, the best response, the best situation outcome is if the reactive client or even the non-reactive client disconnects from the HTTP service, our reactive HTTP service can notice or observe or perceive that reactive response and then disconnect. It can perceive that the client has disconnected and then use that to trigger back pressure on the things that are producing the response. So maybe I'm talking to MongoDB or R2DBC and I'm getting a reactive stream back. If my client that's connecting to my HTTP service disconnects, I can apply back pressure to MongoDB, right? That's the only thing I can do. I cannot, that's equivalent to calling subscription.cancel. I can't also then I can't call subscription.request 5 minutes later. There's no such thing as session resumption, right? So a lot of organizations have looked for more efficient, more robust ways to build network services. Google, of course, they created gRPC. That's a nice approach, but there's some limitations there. First of all, it's only HTTP2, right? So you still have all the problems that HTTP2 has, including the inflexibility. Second of all, it requires Google protocol buffs. So if you want to do anything else, well, you know, you're in trouble, right? It's one way. So it's code generation as well. So my personal favorite right now is something called RSocket. RSocket is a protocol created by engineers from Netflix who work at Facebook now, and the protocol is designed to support natively reactive, on the wire communication. It supports many different kinds of message exchange patterns. So I can do fire and forget. I can do single in to stream out. I can do stream in to stream out as well. I can do single or stream to void, nothing. That's fire and forget. And I can do single to single, right? So all sorts of different exchange patterns there that are very natural. I can send a reactive stream with a never-ending stream of result requests and responses, and that works just fine forever, right? No problems at all. It's also payload agnostic, so it doesn't matter if you send binary data like message pack or Avro or Thrift or CBOR or whatever, or if you send textual data like JSON or XML, you can encode whatever you want inside of a RSocket message. It also supports bi-directional communication. You see, when a RSocket service connects to an RSocket client, they are no longer client service. One side can request anything of the other side at any time. Either side can request anything from the other side at any time. So once they connect, they stay connected for the life of the application. At that point, either side can make a request and either side can send a response. And they can both send requests and response to each other. So that example I was showing you here with data coming from the client with telemetry, this is a bi-directional communication, right? I've got a client that is making a request from the service, and the client is sending telemetry data, right, from the client. And as long as the telemetry data from the client is still valid, then the service can continue producing the response, right? Very natural kind of use case there. So I like RSocket because it's stateful, and because it's stateful, it's you no longer have to worry about constantly making network connections and setting up the network handshake and then and so on, right? It's just a very efficient multiplexed response. And I can also use the same socket, the same RSocket, for multiple in-flight transactions. I can handle lots of them, right? I don't have to, because I'm not blocking. So I can very, very quickly reuse one socket to handle lots and lots of traffic. With HTTP, you have this end of line problem where, the best you can do is in HTTP 1.x is you can serialize multiple requests on the same open connection, but that's only a limited number, and then you have to disconnect and start again. HTTP 2 fixed it with some, it has multiplexed communication, right? So that's a little bit better. So I want to use RSocket. So I'm going to go back to my service in Java, and what I want to do is I'm going to turn this service into an RSocket service. Now you can use RSocket from a number of different protocols. You can use it. You can actually run code. You can run RSocket on top of WebSockets. You can run RSocket by itself as a TCP UDP protocol, TCP/IP protocol. You can also run it on top of Aeron, AERON. So a lot of different ways to run it. There are different client bindings, one for Java, one for JavaScript, one for C++, etc. The Java binding from Facebook is built on top of Reactor. So it's very easy to use in a Spring application in its raw form. But in Spring Framework 5.2, we added support for a component model. So I can do @controller, @message mapping, greetings. And that's it. That's the entire RSocket code base. Now I'm going to start this RSocket port on a service on a separate port, 8888, and then I'm going to restart the application here. So what I want to do is I want to go back to my client, my client node, and I want to talk to the RSocket service that I just changed. So remember, this was service before, and there was no annotation. That's it. That's all I had to do to make that into an RSocket endpoint. Now I can go back here, and I'm going to Java config a RSocket requester. So bean fun RSocket requester equals, and I'm going to same basic pattern. So RSocket requester dot builder dot connect to localhost 8888.block. Okay, so I'm just factoring myself. I'm building a connection to that service, and then here I want to create an RSocket client. So RSocket client, or sorry, listener. Okay, and RSocket requester, application listener. And what I want to do is I want to say rsocket.route greetings, and the data that I get back, I expect that data, the data that I'm sending in, will be an instance of a greetings request object. So Spring fans, just like before. Okay, and then the response that I get back will be a stream of greetings response, just like before. I can use this. And by the way, notice that pop-up there that I just got? That's an extension function in Kotlin. You see this? I didn't show you this last time. I should have explained it. This is an extension function. So in Kotlin, I can add functions to existing types that don't exist in the Java API. So that makes it very easy for us to extend existing Spring APIs to make it more natural for Kotlin users. Okay. So I'm going to take each response, get the message, and then subscribe and print it out. Okay, it. All right, so there's our reactive never-ending stream. Let's go ahead and restart. Oh, I think it's gonna, that should work. Yeah, actually, that should be okay. All right, so there we go. There's our never-ending stream of data, and it's okay. It's gonna it understands back pressure, so I can actually do the right thing on the client, and then apply it on all the way down to the service, and the service will send it back to the whatever service it's using to create the data. Now, I want to quickly add security. Obviously, we don't have a lot of time, so we don't have a lot of time to look at all of the details of Spring Security. But what you need to understand is that Spring Security does two things. It does authentication and authorization. Authentication answers the question, who is making the request? Authorization answers the question, what permissions do they have when they're in the system, once they're inside of the service? So I'm going to bring in the security support here. And we're going to set that up out of the box. Now, authentication can be done a lot of different ways. But what I'm going to do is I'm going to use a simple in-memory username and password database. This is a terrible idea. You should not do this, obviously. But for a demo, it's okay, right? You can use any kind of IDP, identity provider, that you want, right? You can use Active Directory or Okta or LDAP or SAML or OAuth or X509 mutual authentication with certificates, or tokens, or username and password based authentication. You can talk to a custom database table. Now consider that when you do custom database tables, you have to match the incoming password that's coming in from the web or from wherever, and you have to encode it so that it matches what's in your database, and that requires cryptography. Cryptography is going to be one of those things where, cryptography is not going to be great. It's not going to be a good fit with Reactive because it takes time on the CPU. It blocks. So you need to make sure that when you do cryptography, that you do it on another thread. You use a custom scheduler. By default, when you're using Spring Security, it does that for you, right? But again, you just need to know that that's happening, and you need to take care to do that, right? And to make sure that that's scales. You can use protocols like OAuth. OAuth is a great security technology because it reduces the surface area for your username and password to be exposed. And going further, going even a step further, OAuth is a very natural thing to use here because it also reduces the time that you need to do cryptography. So it's actually a better security protocol, and it's faster as well. That's very rare that you get a win-win like that. Okay, so we've got authentication. Now let's do authorization. Here, I want to do security web filter chain. This is for HTTP authorization, server HTTP security. Okay, and all I'm going to do is I'm going to lock down everything, basically. HTTP security .build. Okay, authenticated exchange authorized exchange AE dot any exchange authenticated, and I want to also do CSRF. I want to disable that. Don't need it. Okay, come on. And then I want to do HTTP basic with the defaults. So there's my HTTP authorization. I also need to do the same thing for our socket, right? I want to lock that down as well. So I'm going to do a payload socket interceptor acceptor. Okay, something like that. Index. No. Payload socket acceptor interceptor. That's this class right here. Okay, and this will be our socket authorization. And it'll be a socket security, I guess. Socket server. No, it's our socket server security. Our socket server security. Our socket security. That's right. So our socket security. Okay. And we're going to say return our socket security dot any payload authenticated any exchange dot authenticated. Good. And we want to use, we could use JWT, you know, kind of like, which is a token based approach. But what we're going to do is we're going to use simple, which is like HTTP basic. So simple authentication, enable that by default. Good. So that's basically the same thing. Now, in order for this to work, I need to do a few things. First of all, I want to make sure that we allow, I want to change this endpoint here. Right now, I've got the greetings request. I want to change it so that instead, I have another endpoint, publisher of greetings response, greet, and here, authenticated principal, mono of user details. User, okay? So this will go here now. And I'll say return user.map ud.get username. And I'm going to map that data into a new greetings request user. I'm going to map that gr to a call to this.greet, passing in gr, right? Calling the original version. So, you. And what's the problem with this one? Flat map mini. Okay. And this one here. Good. Okay, so now we've got a flat map. We've got a call. And now, in order for Spring Security to know what to do with this, we need to register one more bean, which is a RSocket Strategies customizer. Okay. Return strategies dot encoder new. Oh, sorry, this is an RSocket message handler that I need to register. Wrong side. RSocket message handler. Turn new RSocket message handler. This one. Return new. Okay, message handler dot set RSocket strategies. We need to inject that, so we say Is that right? I've got this backwards, I think. Var mh equals new rsocket message handler. Mh dot set. Yeah, okay, sorry. There we go. rsocket strategies. Strategies. Okay, and put that here. And mh dot get. Add this new authentication. Good. Return mh. Okay, that's the entire thing. Alrighty, good. So there's our entire rsocket message handler. That's what's going to customize Spring to look for this custom annotation here to make that work. That's the service. Let's go ahead and restart this. On the consumer side, I need to do something, and I need to basically enable my applications to know what to do. So user is going to be JLong, val pw equals pw. Don't do that in real. Obviously, this should be private. Okay, and then we want private val credentials equals username, password, metadata, this dot user, this dot pw. Okay, private val mime type equals mime type utils dot parse mime type, and it'll be well known mime type dot authentication dot get string. Okay, so there's the mime type, and then when we do rsocket connections, we have to pass in that credential. That's for rsocket up there, rsocket, and then for HTTP, we need to set up a filter. So exchange filter functions dot this dot user this dot pw. Okay, so here's what I gotta do for the HTTP stuff. I just go down here, and I can say dot filter this dot eff. Ta-da, that's done. Okay. For the rsocket stuff, I have to set up the connection. I have to set up the credentials. Now I can do that twice. I can do it either on connection or per transaction. So metadata, metadata. There you go. Set up. No, that's not it. Metadata. Set up metadata. This dot credentials. This dot mime type. That goes there. Okay. I can do it there or on the request itself, like so. Right. Either way is fine. Spring Security understands both. In order for this to work, though, we need to teach rsocket how to encode that kind of information in the header. So rsocket strategies customizer equals rsocket strategies customizer. And here, what do we get? We get it. And I want to configure an encoder. Simple auth. Okay, there you go. So I'm customizing how we do, how we can send the information over the wire. So on the service side, here's the client, here's the service. The service looks like it's up. You can see it says rsocket port started there. Then we start this here. Fingers crossed, hopefully it works. There you go, my friends. So every second, we're getting hello JLong, not Spring fans. I sent now, remember, what we're using is we're using the incoming authenticated user to generate the infinite stream of responses that are being sent back there. So now it's doing rsocket authentication as well as HTTP authentication. I hope you got something out of this, my friends. I hope you learned something. I hope you are richer for your time with me. Today we've covered only a few things. We covered Spring Boot 2.3, we talked about the motivations for reactive principles. We talked about how to build reactor-based pipelines. We looked at the reactive streams types. We looked at the SQL and NoSQL support for reactive data access. We looked at the two different styles for building reactive HTTP services. And you can have both in the same application, by the way. It can be functional reactive or Spring MVC style REST controllers can both live in the same application. We then talked about WebSockets. We talked about how to build services. We then looked at building a client. We talked about the reactive web client. We looked at a bunch of different patterns for service orchestration and composition, including hedging and zip and take and tell other and the assembler project. Then we looked at, and of course, we looked at operators in Reactor for degrading gracefully, like on operator, on error resume, and for retry and timeout. We also then looked at RSocket, and we looked at the principles behind it. And then we looked at how to secure both a reactive HTTP endpoint and a reactive RSocket endpoint using Spring security. And these are all things that kind of give us a chance to kind of see some of the sweep of possibilities. But of course, we're out of time. If we had more time, my friends, my goodness, we could talk about so much more. But I'm happy to answer questions now. And I want to say again, Jinkoya, and thank you so much. I know it's still early in the morning, almost. So, it still counts if I say Jindobre, but I know that later it'll be different time. So at least I got that right. Thank you so much. I'm happy to answer questions now.
Yes, okay. So the first question is, it's the only question. Do you know what is the roadmap for the Reactive Stream? Project Reactor is the second generation. What could be except in the fifth?
I don't know. I don't think there's any, like, Project Reactor itself is, we're slowly adding tools around it, like the block count. That's a fairly recent thing. But Reactor itself is, I think, pretty good where it is. A lot of the work that we're doing nowadays is to support evolving Reactor Netty, right? Reactor Netty is the piece that underpins our support for reactive HTTP services, right? So that's an important piece of infrastructure. Same thing for Reactor and RSocket. So yeah, I think stuff on top of Reactor is going to change a lot. RSocket is a brand new thing that we're working on. It's GA. You can use it, right? But it's only in the last few years. And RSocket has been donated to the Reactive Foundation. The Spring team and Alibaba and a bunch of others are co-founders of the Reactive Foundation. And this support, you'll see us adding more and more support for things like a broker, that'll be delivered there as well. So I don't know what we'd be doing for Reactor itself. Good question though.
Okay, so that was the last questions. Okay, thank you for coming to the JAG. It's really late at your time zone, so thank you for this specific. Okay, so if that would be great if some point of time when there is no COVID, you will come to the Wrocław JUG and spend some time with us and tell more about Spring. So that would be great.
Honored to.
Yes, great.
I love Poland. I wish I could be there, seriously.
And we will learn you some new words, not only thank you.
I appreciate it. Yeah, that'd be great. Like I know I've been to several cities there, and I've learned that I don't understand how to pronounce anything. Like the letters don't line up with the way that they pronounce in my. I only speak 4 languages, and none of these languages have prepared me to speak these. Like I have a friend who lives in Lodz, Łódź, but I look at Łódź, the pronunciation. I look at Lodz, and I think Lodz. No, it's Łódź. Oh, okay. There's no way. My brain doesn't understand it at all. So, and my friend, I have several people on the Spring team who are Polish. One is Marcin, and his last name is Grzesiak, I think, roughly.
Yes, so, Grzesiak, yes.
Yeah, and don't ask me how to spell it, but I can pronounce it. But my brain is not big enough to do both, And we've done presentations together, and earlier you saw me writing names down. I was writing names of people on the Spring team, and when we did a presentation once in Poland, we knew that it would be very funny if we did this. So when I got to that point in the demo, when I was writing names, of the people on the Spring team, I was asking him, "Hey, do you have any names I could write for my list here, and he says, "Oh yeah, you can use mine. Grzeziak, go ahead, Grzeziak." And the audience I think like that because I'm a stupid American, so I didn't know, But I appreciate you having me, and I appreciate you being here, and I hope you got something out of it. And I really do wish I could be there. I have friends and so on.
Okay, so thank you all for coming, for staying with us, for asking questions. And Przemek is make a comment that I've done similar presentation many times, and I've seen a lot of them. I watch it again, and I do not have any regrets. Presentation in your style on Polish Jack is completely different thing. Yes, I will agree that Polish Jacks are really, really active people, so you would have a lot of fun doing a presentation alive with us. So again, I invite you to the Poland if there will be any occasion. Thank you all for coming, and have a nice day, and have a nice night for you, Josh.
Thank you. Bye, everybody.